Thanks for watching this video and don't forget to like, subscribe to the channel and activate the notifications. It's very important to the continuity of this channel. The equation of state of an ideal gas. We have already seen how the gas laws describe the experimental relationship between pressure, volume, and temperature for a fixed mass of a gas. They are empirical in nature, meaning they are not based on theory, but arose from observation and experimental evidence. The three gas laws you need to be aware of are: Boyle's law. When the temperature is constant, pressure and volume are inversely proportional. Charles' law. When pressure is constant, volume is directly proportional to absolute temperature. The pressure law. When volume is constant, the pressure is directly proportional to absolute temperature. The absolute scale of temperature is the Kelvin scale. We will now combine the results of the three preceding equations to find the general relationship between pressure, volume, and temperature of a given mass of gas. An equation relating temperature, pressure, and volume is called an equation of state. At state A, we have the gas occupying a volume V1 at a pressure P1 and a temperature T1. We wish to calculate its volume V2 at a temperature T2 and pressure P2 as at state C. We proceed via state B, raising the temperature of T2 while keeping the pressure constant at P1. If V is the volume of the gas at state B, then, by Charles' law, we have the equation. We proceed now to state C by increasing the pressure to P2 while keeping the temperature constant at T2. By Boyle's law, we have the equation. Eliminating V between these equations, we get a new equation. This equation shows us that as long as the number of moles, that is, molecules of the gas remains the same, the quantity pressure times volume divided by temperature is constant for a gas regardless of the process through which the gas is taken. This relationship is called the equation of state. The constant is dependent on the amount of gas used measured in moles. Therefore, we can rewrite the equation of state in two different forms. Pay attention. N is the number of moles of the gas. R is the gas constant. N is the number of molecules. Kb is the Boltzmann's constant. The two forms are related through Avogadro's number and A through the formulas. We will now summarize all of this. The three properties needed to completely define the state of a gas are pressure, volume, and temperature. Hence, for a gas, the state variables are pressure, volume, and temperature. An equation of state is a relationship among the physical variables that describe the condition of a gas. We can write the equation of state of an ideal gas in three different ways. If a gas starts in state 1 and is altered to a state 2, suppose the number of molecules of the gas remains the same in the process. Then These two different states are related to each other by the equation. This equation is called the proportional form of the ideal gas law. This formula is particularly useful when describing an ideal gas that changes from one state to another. Since this formula does not use any gas constants, we can use whichever units we want, but we must be consistent between the two sides. The next formula is known as the molar form of the ideal gas law. N is the number of moles of the gas. R is the gas constant. If you will want to use the number of molecules instead of the number of moles, we can write the ideal gas law as the molecular form of the ideal gas law. N is the number of molecules in the gas, and Kb is Boltzmann's constant. The equation of state of an ideal gas is an approximation that gives good results for gases that are not very dense at temperatures and pressures near those in which we live. A cylinder contains 12 liters of oxygen at 20 degrees Celsius and 15 atmospheres. The temperature is raised to 35 degrees Celsius, and the volume is reduced to 8.5 liters. What is the final pressure of the gas in atmospheres? Assume that the gas is ideal. Since we know the temperature, pressure, and volume at one state, and we are trying to relate it to the pressure at another state, we will use the proportional version of the ideal gas law. We can do this since the number of molecules in the sealed container is constant. Do not forget to convert the given temperatures to kelvins. The next question asks us to find the number of molecules. So we use the molecular form of the ideal gas law. This question asks us to find the number of moles. So we use the molar form of the ideal gas law. Do not forget to convert the given temperature to Kelvin. We now can calculate the mass of air. Mass is equal to number of moles times molar mass.